and good morning, Dzień dobry. Welcome to the talk, Java Value Types, the next big thing for Java. And now, there we have. Here at the GeeCON in the multi-kino in the beautiful town of Krakow. And as Twitter says, hashtag GeeCON. So I know we're all a bit tired. That's why most of you come so late. And we all had a couple of beers last night and were like this. I don't know if you can see it. So the first thing I want to do with you is a little exercise. So I think this event is a great conference, and especially the party yesterday, I enjoyed very much. So I ask you, organizer guys, please come in front. And everybody else, please also stand up. Please stand up. And now let's go for a big applause for the organizers of the great GeeCON 2017. And selfie time. Great. Thank you very much. And then don't sit down, please. Please stay up. And it would be great if you came to the front and to the middle, so we have a compact and condensed audience. So the people that come later, they don't have to go through the line. So please go to the middle. And you know what I mean? Not really. Okay. Thank you anyway. Okay. That's me. My name is Henning. My name is Henning Schwentner. That's hard to pronounce, something like this, Schwentner. And of course, I'm on Twitter. There I'm Schwentner. And under the same name, you can find me on GitHub and Instagram, and of course, Snapchat. So that's the social media you have to use. I studied computer science in the University of Hamburg. I like good food, good football, yoga, and I'm a proud dad. But of course, here I am to talk about work. And talking about work, I work as a consultant, as a software architect, as a coach, but to be honest, mostly for German teams. Most of all, deep in my heart, I'm a software developer. I'm a programmer. So that's why I like the name of this conference, especially the GeeCON. So, most of the time I program in Java, but I have to be honest, I also look onto the dark side. I do some projects in Microsoft and C#, and I spent a couple of years programming SAP with ABAP. And I live in Hamburg, in Germany. There I work for a small company. It's called WPS, Workplace Solutions. That's Whiskey Papa Sierra, WPS, Whiskey Papa Sierra. And we're 75 software architects, software developers, most of us IT guys. Even the girls you can see there are programmers. And our motto is enjoyable business software, or in German, business software, die Spaß macht. Okay, why do I tell you that? Yeah, because classical business software, the classical IT workplace, that's something like this: mouse, keyboard, everything is gray. The good thing is, today, not everything is so gray anymore. We have smart devices which we can use for work, like smartphones, tablets, and even bigger touch devices, like this one. This is a touch table, a multi-touch table, and the great thing about this is you can use the multi-touch thing in this size for multi-user interfaces. So you can have a lot of people standing around a table and you can do cooperative work. Okay, and the next thing that's going to come from gaming to the workplace to serious applications, that's augmented reality and drones, I think. We're spending some time with this. Okay, that's why we're calling it enjoyable business software, because we want our users to have fun, to enjoy it. But we also want, as developers, to have fun, to enjoy programming. And that's why I'm talking today about value types, because I think when we will have value types in Java, then programming with Java will be even more fun. Okay. Disclaimer, I am in no way affiliated with Oracle. So everything I tell you, I have learned from the outside, which means the internet. And that means I'm trying to tell you the truth, but if not, I will just tell you that's alternative facts. Okay, value types. This is James Gosling, the father of Java. And as we're on a Geek conference and as we're talking about a programming language, there will be some code on the slides. I hope that's okay for you. But if not, don't run away. You can still click on your smartphone. This is the access data to the Wi-Fi. So for everybody else, now let's start. Value types for Java. Why are we talking about them today? I heard the first time about them at another Java conference, a big Java conference in Germany. It's called JAX. Maybe one or the other of you knows it. And there I heard a keynote from one of the Oracle guys who's working at Oracle on the Java language. It's Brian Gertz. And he told us what was then new in Java 8, so things like lambdas and the streams API are optional. But he also gave an outlook on what would come with Java 9. You heard that 2 days before when you were in the talk. That's the most important thing is, of course, the module system with Project Jigsaw. And he also looked even more into the future, what would come with Java 10 or maybe 11, it's not so sure. And he said the next big thing for Java are value types. And when I heard that, I was happy. And why is that? That's because objects and values are two fundamentally different concepts. And I think it's a good idea to have them both in the programming language so we can express them both. And more important, it's not only a technical decision, it's only a business distinction. That's also in the domain. So also in the domain, we have things that are objects and things that are values. And since software is a model, is a reflection of the domain we have, we can build software in higher quality and better understandable code when we can express the things that are values directly in the code. So, what's the current state in Java? As you all know, Java is an object-oriented programming language. And that means objects are at its heart, at its core. So, what is an object, actually? An object has an identity, and it exists in time. So, that means it has a life cycle. An object gets created, then it can change its state from blossom to fruit, for example, and it is destroyed sometimes. And then the garbage collection comes and cleans everything up. Okay, that's objects. Values, on the other side, they don't have an identity, and they are abstractions, some kind, and they exist in a way out of time. They are immutable, so they're just there. They cannot change. Okay, to be more concrete, I'll give an example of a value. When we look at all the couples in the world, all the pairs, then an abstraction of all these couples is the concept 2, the value 2. And if we now, one of the couples decides to separate, to get divorced, that does not bother the concept 2. The value 2, the concept 2 is still there. And even if all the couples in the world say, let's get separated, then still the concept 2 will be there. It's timeless. So that's more of a philosophical view. Of course, we're not philosophers, we're programmers. What's the programmer's view? We also like growing long beards. And what's the programmer view? What's in Java? In Java, we have objects, and these objects, they are built from classes. And we as programmers can define classes, and from these classes, objects. And this is the class, the form with you can cut out the cookies, at least if you think of code as cookie dough. So then this is the class, those are the objects. And then these objects can change their state, like this, or like this, and then they will be destroyed. Okay, and identity, identity is implemented with the reference, the memory address. So that means these two variables, here on the left are the variables. These two variables are equal, or maybe equal, but they are not identical, because they have a different reference, different objects. And these two variables, they are equal and identical, because they reference the same object. Okay. An important question is, where does an object actually live in the program? And the answer is on the heap. Okay, what does that mean? What is the heap? When we look into a process, so a program that's in execution, then the memory of this process is roughly made of two areas, the stack and the heap, or core stack and the heap. The stack, that's something like this, a stack, and at any given time the process is at one place, at one point in the programming, in the code, in the program code, when we talk about single-threaded code. And when at this point in the code a method is called, then the parameters for this method are pushed on top of the stack, or the core stack. That's why it's called a core stack. When I call a method, I push something on the top. The parameters and the local variables, and then you can work with it in this method and change the state of the variables, and then you're done. The method is done, the core stack is cleaned up, every local variable and parameter is cleaned up, and the return value is pushed onto the top, and then we're back in the calling method. Okay, and the good thing is, we know at compile time how much memory we need for such a method call. The heap, on the other hand, that's just a big pile of memory from which you can get chunks in the size you need. And how much memory you really need, you only know at runtime. Okay, so now we know an object lives on the heap. That's objects. On the other hand, values, how about them? Values, they're not reference types. They can lie directly in the memory. So this means these two variables, they are equal, and talking about identity, well, that doesn't really make sense because values don't have an identity. So equals and the equals operator are the same. Okay, and they can live on the stack. They can live on the call stack because they live directly in the variable itself. Or in the objects they are defined. You don't have to go through a reference to get them. And that's something good, as we had before. The point is, in Java, even with version 9, we still have only eight value types, only the built-in value types. Let's int, double, boolean, float, and who's still awake? What are the others? Kara? Louder? Long, short, right, and byte. Great, thank you. Bin cool. So, what we don't have is user-defined types. So we can, as a programmer, we cannot define new value types. So we don't have things like this, unsigned or complex, technical types. But we also cannot have things like this, domain value types, IBAN, a bank account number, or a postcode, or an amount of money. So and that's not so nice. What you can do is build yourself a crutch. That's called a value-based class. That means I define a class which can then instantiate objects which behave like values. So we remember what is a value. That's a thing that does not have an identity and is immutable. So we can simulate that with classes. We can say we only have final fields, and we only have methods that do not change the state. Of course, when you only have final fields, we cannot have methods that change the state. So that's the immutability. And for the identity part, we define equals so that it does not depend on the identity that is the reference. So for value-based classes, we always have to override equals, because the standard implementation of equals in the object class depends on the reference. And if we override equals, of course, we also have to override hash code. Okay, then we have a value-based class. But still, we have problems like this. Also, reference-based classes, or the objects from reference-based classes, are reference types. So we still have variables that are references, and we have to dereferentiate. And still, the equals operator will not work on this, although we have values. And the other thing is, the objects from value-based classes have, of course, to live on the heap when we have this. And we cannot pass them by value, of course, we have to pass them by reference. And also we have to do the dereferentiation effort. And of course, we need more memory. And that's especially the case for the small things that values typically are. So we need twice the memory for a thing like this, because we have the variable, that's what integer, and a pointer or reference, that's also 32 bits or 64 bits, depending on your system. It's twice as much memory as this one. And that gets worse when we have more than one thing. When we have a couple of things, like in an array. When we look at an array of ints, there we have neatly lying values, one after the other in the memory. But when we look at an object array, we don't really have an object array, we have an array of references to object. So something like this. The array is on the top with the references, and then we have pointers to all the real objects. And of course, these objects, they don't lie in the memory one after the other, so they're somewhere on the heap. So it's not easy to loop over them. You always have to find them in the memory. So we don't want lists for values, we want them to be directly in the array. Okay, so now we've seen the problems. And what's the answer? Yeah, the answer from the Java team is they say, okay, let's make it possible to define value types as a programmer. Let's not only have these 8 built-in types, let's have user-defined types. Let's make value types first-class citizens. And they built a project for it. It's called Project Valhalla, like the heaven in the northern mythology. And they have this war cry, works like an int, codes like a class. Okay, what does that mean? Let's look at an example. This is a coordinate system, and a typical value would be a point up there in the coordinate system. And something like this, x and y, 2 are coordinates for 1 point. Okay, how would we implement that with Project Valhalla in Java 10? So beware, this is still under construction, so the syntax we see is ugly, and that's by intention. It's only a strawman syntax, so that nobody should think this is going to be the real syntax where we will have in the new version. So a value type then will something look like this. So we will have a class point, a type point, and there a new keyword, underscore by value. There's the strawman, that's the ugly thing. With this, we mark this class as a value type. And then, of course, there can be only final fields, and these fields, of course, have to be instantiated in the constructor, initialized in the constructor. And equals has to be implemented, and it has to be only on the fields. And of course, when you implement equals, you always have to implement hash code. Okay. And also the type in total has to be final. Why is that? That's for technical reasons, because when we look at this point, which I go back, at this point it's made of 2 ints, so that takes 64 bits in the memory. But if we could make a new class that would inherit from this point, we could add new fields, and that would be a problem because we wouldn't know at compile time how much memory this new point would need. And we want to pass them by value, we don't want to pass them by reference. So they have to be final. Okay, then it looks in total like this. Okay, that pretty much codes like a class. So what's the other side? What's with the works like an inside? Is that also true? There is a bit of a discussion going on how we will do it. So this is how we define a new variable point p. And then we have again this ugly strawman syntax, underscore, underscore, make value of 4 and 7. And how make value will be implemented, that's in discussion. For example, one thing is just let's do it like we do it with objects. Let's say new point. Sorry. Let's say new point. So the good thing about it, it's the same like an object. You don't have to remember anything new. But the bad thing is, when you think about new, you also think about reserving memory and stuff. And that's not what you're doing with value types. So another possibility is this. Just say point. Leave out the new. Or even let the point away and just say p is 4 and 7. Okay. That's the syntax. What would it look like in memory? We wouldn't have anymore this, what we have in a value-based class. When we have a value-based class of point, we have something like this. The values could be directly in the memory. And they don't have to be on the heap. They can be on the call stack. So we have to, we can pass them fast. And this is even more a point when you see that these are old systems, 32 bits. These are the system we're using today, 64 bits, where every reference is 64 bits. So this is better, of course. And the differentiation effort, oh my God, is also saved when we have something, when we will have something like this. And the equals operator and the not equals operator, they will be implemented that they call the equals method, so they would work as expected. So we can finally compare values with equals. Yeah. An interesting thing is the default value. What are we doing with this? For reference types, the default value is easy, it's always null. But for value types, we cannot have null because we're not referenced. So we always have a value we do not point to nowhere. There is something, always. So that's why the built-in types, they have default values like 0 or false. And what they are thinking about is that they just say, okay, let's make the default value something like where we use the default values of recursively of the values we are made of. That's the one possibility. The other is, okay, let's just define every type its own default value. Okay, look for the watch. We're still at 160 slides. That's not true, it's more like 260 slides. And so, what else is there? Yeah, we will have things like this, list of point, and we also have less references. And there's another project going on how value types and generics will work together, because we have type erasure, and that will be problematic. And what we can hope for is that we can finally get something like this, a list of int. We don't have this now. We now only have a list of integer with a big I, where we have the box type, and we have a reference to a list, which contains a reference to an array, which is an array of references to integers, which contain ints. That's a lot of references. And when we have this, there will be a lot less. Okay. Yeah, talking about boxing. This is an open question also. What does this actually mean, list point? For the built-in types, we have this box type with great letters. So there's int with a small I and integer with a big I. One is the box type for the other. And we will also need box type for the user-defined value types. And there's an open question, how can we distinct them? Okay. Now we've talked a lot about Java. What about other programming language? Even this is a Java conference, I think it's interesting to look what other people are doing. When you look at C#, there you can define for every variable you can choose. Should it live on the stack or should it live on the heap? So point P in C++, this means that's a stack variable. Beware. In C++, this is a stack variable. In Java, this is, of course, a heap variable, a reference variable. Okay, and this is the way you initialize it. There's also no new keyword, you just say the type. And then it lives on the stack, okay. And then you have pointers, and with pointers, you're always on the heap, and, and you can initialize or assign a pointer like this. We have this new keyword again. Okay, and then it's a reference type. And then we also have references in C++, but we're not talking about them today, just that you heard it. That's in C++. What about C#? They have value types, but they call it structs. So these are things that are not reference types, they are value types. They live directly in the variable. And not on the heap, but on the stack. And of course, there's also no inheritance. But the strange thing with C# value types is they have mutable state. So for me, they're some kind of strange values, because the usual definition for value is no identity, immutability. And in Java, we will get both. We will not have this changeable state. And then they have an interesting concept, that's the concept of nullability. So even with value type, you can have null when you use this type. Okay, that's C#. So now I've talked a lot about technology, and yeah, that's good. We're on the GeeCON, it's a technology conference, and that's our life. Talking about technology the whole day and then dreaming at night about it. But beware, I'm sad I have to tell you this, but technology is not important. Software is not an end in itself. We always build software for a purpose, and technical beauty alone will not help us. And what is the purpose? What is the goal? Yeah, the goal is this person here before the computer. We have to support them in their work, what they do. That's more important than every technical beauty. So, and what we do not want to support them is an anemic domain model. So we want a rich domain model, something that domain-driven design helps us with. And maybe you know the tactical design of DDD, and there we have the so-called building blocks. And one of the building blocks is the value object, which is kind of a strange name, because I think it's either a value or an object, but they call it this thing anyway. And of course, I think a better name for value objects would be domain values. So things in the domain that have a value character. Things like this: postal code, IATA code, GPS coordinate, container number. And what DDD says, these things become part of your ubiquitous language, of the language we as developers share with our users. So we look at the domain, we see the concepts we have there, the things that are more like objects, they are called entities, and the things that are more like values, the value objects. And we want to have them both in the ubiquitous language and in the model and in the code. And that's what we can do with value types. Okay, let's look at an example. This is a class that's a bank account. So it's a very simple implementation. It just has one field, an integer, the balance, the money that's currently on this account. And what we want to do with a bank account, we want to go to the ATM, put our card in and withdraw money from it. So we have a method, withdraw, and we withdraw an amount from it. And of course, there's other stuff, but that didn't fit on the slide. So this is what our account looks like. But what we typically also want is something like this. We want a currency, because we want to know, is this account in euro, or is it in zloty, or whatever. So we add a new field, currency. And then, when we look at the method withdraw, we would also want a currency. We want it there, and we want it there. And of course, then we want to check, we can only withdraw the same currency like the account is in. So we have to implement a check, a precondition. So in total, it looks like this. But of course, we do not only want to withdraw money, we also want to deposit money. And there we have to do the check again. So we have the same check in two methods, withdraw and deposit. And of course, we would want to have to do this check everywhere else. We would use money. So wouldn't it be much nicer if we didn't have these ints and strings, but a real type, a domain type? Yeah, of course, it would be. We want to have our own amount type, a value that encapsulates all these things about the money. And that would look like this. So this can now have two fields, amount itself and currency, and they're always together. And of course, they're finite because we want to have a value, and that's why we initialize them in the constructor. And then we can have business logic methods. So we can have a business add, where we can check when one amount is added to another amount, they have to have the same currency, because otherwise we cannot compare them. And then, of course, we would have to return a new amount. Why is that? That's always the case with values, because we can change their state. We cannot change their state. They're immutable. And of course, new methods come to it. This has same currency method. And we go further. Of course, we want to have a currency type as well. We don't want to use string. But we don't look at this at any more detail. Okay, then we have an amount type like this. And when we have an amount type like this, we can then use it in our bank account. So we just use, instead of the type int, the type amount. And we can then use business logic methods like subtract or add. And we can concentrate on what's really important and what's coming from our domain. Things like that we cannot withdraw more money than what's on the account. So we can express more preconditions, more assertions. Yeah, that's nice. Then we have a rich domain model, and then somebody comes and says, all these amounts, they are taking too much memory because they are reference types, and that costs us performance. And then you have to go back and convert everything back to int to make it fast. And then you have an dynamic domain model again, and we don't want that. And that's the nice thing about value types. With value types, you can both have it. Eat the cake and have it. High performance and a rich domain model with a rich behavior. So the only thing we would have to do then is take this class amount and make it a value type with this underscore by value, or whatever operator it will be later. Strawman syntax again. Okay. So coming to the end, when you look at value types, you can see there's still a lot under construction. So it's a good idea to stay tuned and look at what's happening. So further reading is Googling Project Valhalla. That's how it's written, with a V, like value. And they even have their own Wikipedia entry. Take a look at that. And if you're interested in domain-driven design, then this is the Bible from Eric Evans, the big blue book. But this is more concise, not so long, only 120 pages. Domain-driven design distilled. Maybe you want to take a look at this. And if you're more of a hands-on guy and want to take a workshop, then call me. And I'm giving workshops 2 or 3 days on DDD and rich domain models and value types, DDD concrete. And of course, I have a flyer here with me. And talking about advertisement, or Werbung, as we say in German, I will take this occasion and say to you, do something good, make a blood donation. And yeah, of course, feedback is always important for us as speakers and for the conference organizers as well. So please tell me on Twitter or via mail, or come to me directly, or tell the conference folks, but of course only the good things. And I've come to an end. Thank you very much. This is it. And Enjoy the conference. Thank you. And if you like, I think we have 2 or 3 minutes for questions.
Hello.
Hello.
I have a question about overloading operators for volutiles. Would it be possible to do it in Java 10?
The question is, will there be operator overloading in Java 10? And the answer is no. They don't want it. The Oracle guys, they say Java has to be a simple language. That's what we all wanted since version 1, and that's why we never came up with operator overloading. I think with what we have now with Java 8 and then Java 9 and Java 10, that's not anymore a simple language, but that's what I want. So you would still use, would still have to use C++ or C#. Okay. More questions? Okay, then thank you.